So the CUDA has an excellent Power 8 IBM node structure, and I'm particularly interested in the NVIDIA GPUs, the K80s. So these are very powerful GPUs with thousands of cores, and once people learn how to program using these, the performance of what they can achieve is really very impressive. So that's really been the point of the course this week, is to try to increase people's knowledge and understanding of GPUs so that they can get the most out of the CUDA system. So with a system like CUDA, there are two ways in which you can use it. One way is to use application programs which have been developed elsewhere by other people. So for example, in machine learning, there are packages like TensorFlow and Caffe, Torch, Theano. So you can obtain those codes, and then people here can run those codes on CUDA. The alternative is you have people here who write their own new codes, using the CUDA programming language. And that can be used to do any area of science or engineering, writing their own algorithms and achieving really high performance. In terms of future workshops, Professor Grivank is already saying that at the Department of Mathematics, perhaps they will put on the same kind of course in the future using the lecture materials that I have left behind. So all of my lecture slides and practicals will stay here, and so maybe somebody here will teach the same course in the future. Also, there's a lot of information available now on the internet, and in particular NVIDIA, who produce these graphics cards, they run a major conference called GTC, and all of the talks at that conference are made available on the internet. So people here can learn all of the latest techniques, learn about all the latest developments coming from NVIDIA, just sitting here looking at these displays on the internet. The idea of developing Yache Tech University, and as a leading university both in research and in education, I think that's a wonderful idea, and the ability to bring in faculty from many countries, not just from Ecuador, I think that's an important part of establishing a top university. So I come from Oxford, and the faculty in Oxford come from all over the world, not just from the UK. So the things that I have done myself probably don't relate too well to the Ecuadorian situation, because I've worked with Rolls-Royce on designing jet engines for aircraft, and I've worked with big financial banks in doing their things. But one sort of example area, before on the screen you had a map of the local area. So these days you could imagine using drones to go out mapping, and that will then require processing power to combine all of those images, to overlay them onto Google Earth. So you're basically updating the Google Earth maps. You could use that to monitor construction in various places, monitor agriculture, see crop development, provide advice maybe to farmers on ways of increasing their crop yields, monitor development, check that in the Amazon rainforest people aren't cutting down the trees when they shouldn't be, and things like that. So I think computing comes into all aspects of life. So you just have to decide which application areas in the economy, in society, are most important to Ecuador. And I think there will always be applications then of both mathematics and computing to assist in those areas. So you need to have this kind of computational infrastructure to support that activity. And also having a national system, so I believe that Kindi can be used by lots of universities elsewhere as well as here. So it's a very important role in bringing together the academics from different universities to collaborate, to talk to each other, so that each university isn't just a separate island.